In this video, we will sketch the graph of f prime of x based only on the graph of f of x. Now, in such situations, you want to look for places where you know the derivative exactly, and such places include horizontal tangents, and if they're on the graph there are line segments. Those will be good because we know that the slope of that segment will be the derivative on that entire segment. Okay, so we start with the horizontal tangents. We can see that there's a horizontal tangent at x equals 3. There's a horizontal tangent at x equals 6, which means that 3, 0 is on f prime because the derivative at 3 is 0, and 6, 0 is also on the graph of f prime. Now, we look at the line segments, and we can see the segment for x less than 0 passes through minus 2, 0, and 0, 4. So the slope is 4 minus 0 over 0 minus minus 2, or 2. The section of the graph between 0, 4 and 2, 2 is also a segment. The segment between x equals 0 and x equals 2 has slope 2 minus 4 over 2 minus 0, or minus 1. And we notice at 0, there is a corner. There is not a corner at 2, by the way. So f prime of 0 does not exist. And we end up drawing the following graph. Here, we're x less than 0, and we said there the slope of our graph was 2, so the derivative is 2. Between 0 and 2, the slope of that graph was minus 1, so the derivative has value minus 1. And we have the 2 points that we already know about. Now, between x equals 2 and x equals 3, we can see that the derivative is negative, but it gets less negative as we approach 3, which means that the derivatives are going to be negative, but increasing towards 0. And that gets us this sort of a shape. Now, between x equals 3 and x equals 6, the slopes are positive, and they get bigger for a while, and then they get smaller again down to 0 when we get to 6, and that gets us this sort of shape. And then finally, when x is bigger than 6, we have negative slopes, and they get more negative as we head off this way, which gives us this picture. And that's a fairly accurate sketch of the graph of f prime.